Good afternoon, everybody. Thank you to our Tech Talk this afternoon. So my name is Sven. I'm more than 14 years with Milliken, serving as a technical service engineer in different divisions. And I will be your moderator for this afternoon for Dane's presentation. He has more than 8 years with Milliken in various commercial roles. Now he is acting as a global product line manager for additives for engineering polymers. He will talk about laser marking additives used with the focus on polyamide. Okay, Dane, the floor is yours.
Brilliant. Thanks, Sven. I'm going to talk today about laser marking primarily for polyamides, but I want to start with a more general look at laser marking for many different applications, because as Milliken, we come at this from a very diverse position. Our product portfolio today is, when we look at the synergies we have with laser marking, it's really interesting. So we start from a position of approaching the market with something like our Millad NX8000, now superseded by our 5th generation Millad ClearX 9000. We have a great deal of expertise in polypropylene specifically and transparent polypropylene, which is a huge area for laser marking that we're really looking to get into in the future. And I want to set the scene a little bit with that. But also with our colorants business, which is broken into 2 different places. Our resist products for high heat engineering polymers, polyamides specifically, and that's really what I'm going to focus on today. But the other area where we really have some great synergies is in our EXPLAZ colorants for PET, where we see the market for laser marking is moving very fast, with a lot of brand owners looking to combine laser marking additive solutions in order to achieve more sustainable solutions for packaging. So we come at this with a lot of synergies. I'm really eager to learn about these new applications and really bring something new to the market. So as far as what we're looking at today, it's mainly polyamides that we start with, and this is where we have the expertise from our resist products. So the product we're introducing today is EXPLAZ HT34D. And this is a product designed for high heat engineering polymers, and we're starting with polyamide 6 and polyamide 6,6 because we really see the synergies with our resist product range here. Thank you, Sven. So the value propositions that we're really focusing on today is having minimal impact on the base color of the polymer. So one of the challenges that our customers are starting to talk to us about is how to achieve really whites, bright grays, and bright colors, and still maintaining the laser markability of polyamides. It can be a real challenge to color match across different polyamide formulations, whether they have a laser marking additive in them or not. When you start to incorporate an additive such as this, it's typically gray, it typically has some impact on the color of the base polymer. So maintaining a consistent bright orange or a very bright white across many different polymers can be difficult. And that's one of the challenges we're trying to address with this product. I mentioned the brighter whites as well. A lot of the applications we look at today are in appliances or in E&E, where we see a lot of the shades are RAL shades, which require very high L value. So we're trying to overcome that challenge of really enabling people to achieve whites in PA6 and PA66. So what we've been able to achieve with our product is highly readable markings, and we've done a lot of work building out the readability of these products in different polymers. And we're confident we can achieve class A and B markings at quite low loading. So we're typically looking at 0.2 to 0.8% loading of the laser marking additive itself. It's obviously tunable to the formulation and to the end polymer too. So I'm going to show a quick video now of what laser marking polyamide 6,6 looks like without an additive. And what you'll see is nothing, basically, which is good. That's supposed to happen, don't worry. Polyamide 6,6 is not inherently laser markable. You need some additive in there to achieve the contrast and for anything to happen in combination with, in this case, an IR laser, which is what we've chosen to invest in. Now, if you contrast that with the use of Milliken's laser marking additive in polyamide 6,6, what you'll see is clear, readable markings with very good contrast. that are quite easily achievable with an IR laser, like I said. So when we look at this application space, I already mentioned E&E and appliances specifically that we're very excited about in terms of polyamides specifically. But there's also other things we want to get into. We see the trend in consumer goods for personalization, for example. We know people want to see their name on their own products. We know people want to see QR codes for traceability in things like electric vehicles or electronics application, for recyclability purposes, to be able to replace these products in the long term. It is actually something that contributes to the sustainability of these applications, and it's something we want to really encourage. There are other applications that people are also familiar with in terms of TPU, for example, for the animal ear tags. It's not something we're working on at the moment, but it's something we're aware of and we'll be interested to look at in the future. So it's a real diverse application space. So really the challenges we're trying to address with this specific product is, like I said, it's avoiding the gray shift in white formulations. That's our number one priority. We want to be able to achieve those bright whites. It's the consistency of the color matching across different parts. Having to use less pigment to achieve high chroma colorants is one benefit. And also having that reliability that the parts that are marked can be scanned and can be readable for 6 months, 12 months, 5 years, 10 years after they've been marked. It's really about reliability. That's the core of what the product does. So to give some images, this is one example of our, without our product actually in there. This is PA6 with titanium dioxide. Titanium dioxide does actually aid laser marking, but it's difficult to achieve clear, readable results. So this is with no laser marking additive in. With just 0.2% of our product, you can already start to achieve some markability. The contrast can be optimized depending on the settings of the machine, the intensity of the power of the laser, but also the loading as well. Because when we move up to 0.5%, for example, it becomes much more readable. And you can see the whiteness of the polymer is pretty consistent from 0% up to 0.5% of the additive itself, which is really encouraging. And it's in line with what we want to do with our customers, letting them achieve these kinds of shades. Also, when we talk about the darkness, we also did some experiments in combination with zinc sulfide, for example, with PA66. And you can see the impact of the alternative solutions for this application on the right-hand side here. You can see the progression of the loading from 0.2 all the way up to 1%. If you look at the EXPLAZ, you can see some impact on color, but then you can benchmark it against the alternative and see how much darker the results are. So it's a real challenge to start from a dark gray if you're trying to achieve a RAL 2003 orange or specific grays that have a slightly higher L value. So when we really start to quantify it in terms of the Delta E CMC, you can see the variation of the EXPLAZ in contrast to the current market alternative. So we're talking a Delta E CMC difference of around 2 typically as we build up the loadings. So it has value in terms of being able to color match consistently across different components, which we see has value for a lot of our customers who are trying to achieve, like I said, the bright colors and the bright whites. Specifically with the L value, it's just one that I find very interesting, is we start from the assumption that all these laser marking additives have some negative impact on the L value, but with ours it's again severely reduced versus the current alternative. So whereas we start at 0.2% with a almost -14, -15 impact on the L value, the EXPLAZ is more like -9, -10. So we're really excited about the applications we can open up by focusing on these whites and these lighter gray colors for electronics and appliance applications. So you can achieve the dark colorants at very low loading. We've done the experiments as low as 0.2% here. We'd be delighted if people use it up to 1%, but you can achieve good results with 0.2, 0.3, 0.4, depending on the formulation. And they're readable. This is the key thing. We can make a visual assessment of how good these products look just by assessing the QR code and how dark it looks to our eyes. But really the key thing is the readability as per the sensors that people are using in factories to judge these. And so we use some technology from Keyence. That's a specific instrument to grade the quality of the markings, and that range can be from A to F. We can achieve A standards, and I think this one's a B at a very low loading. I believe it's 0.2%, which is fantastic. It tells us that the product is very efficient in terms of its cost in use, and you can achieve the desired results without having to use 0.5, 0.8, or 1% loading like you need with some other additives. Also in color formulations, we've done some experiments with our resist products in orange. We can also achieve very readable QR codes in those types of formulations. So we see the trend in electric vehicles especially to mark these bright orange connector components. Again, for replaceability, for recyclability, these QR codes can be very easily read at low loadings without also impacting the brightness of the color formulation as well. So you can achieve still a bright high chroma RAL 2003 without necessarily having to use as much pigment as you might otherwise with the current market standard. What I'm also excited about is new products, where we go in the future with Milliken. So I call back to the first slide where I talked about our synergistic products. Now we're talking about polyamides. What I'm also excited about is what we can do in packaging applications, especially in collaboration with our clarifiers and other products for polyolefins. We have a developmental product suitable for polypropylene, which has limited impact on haze and the transparency of the clarified polypropylene. And we are hoping to launch this next year. It's the second product that we'll have in this portfolio, and we expect that we'll have many more as we go forward. Right, Sven? Yeah, he's on board. So to summarize, with the EXPLAZ, you can achieve very clear, readable markings even at a very low loading. You don't impact the color in the same way that you do with current solutions, so you can achieve consistent coloration across polymers without going too dark. And it's also compatible with all of our resist colorants for polyamide. So really think there's some great synergistic wins there. I'm just excited to get this in front of customers and get some feedback and see what we can do with this this combination of products. So I think that's it. Thank you for your time. I appreciate it. Sven?
Thank you, Dane,
Thank
for
you.
your insightful presentation. Now we'll move to the Q&A session. Some questions from the audience.
Can you comment on the system working well in filled systems also compared to unfilled systems like glass fiber, 20%, 30%?
Yeah, it's a great question, and actually we've just done some work on it. You can give that back to Sven. So what we see is that there's not a huge impact on the mechanical properties, but we can benchmark it against current alternatives in the market, and we don't see a worse performance, I can put it like that. So you do have some impact, but certainly not worse than what we see in the market already. So we have a full data set that Sven has generated in the past few months, which is interesting. So yes, some impact, but not worse than what we see in the market already.
A second one maybe on recyclability.
Sure.
I mean, I have post-industrial waste. I want to put it back in there. Will it work? Do I need special precautions? What can you say about that? Or what's your feeling about that?
It's a great question, and Sven, please. And in terms of recyclability, this is one of the main areas where I'm interested in what the portfolio can do in the future. Because when we look at polypropylene, for example, and especially the recyclability in Europe, one of the constraints can be things like inks, labels, azo pigments, azo dyes, polluting the recycle stream. This is something we could potentially start to address with laser marking additives. We see brand owners like Procter & Gamble moving in this direction. One of the constraints is actually the machinery rather than the additive technology. It's about how fast you can mark thousands and thousands of shampoo bottles or PET bottles versus printing them or putting a label on them. So I think the constraint is less the additive technology and it's more the machinery itself. But I know people like Procter & Gamble have developments there, and it's something that we'll look at as well, is how can we partner with the laser marking machine manufacturers to help them improve their technology and kind of find the synergies with our additives. So it's something we want to address as we develop the portfolio.
Dane, I have a question for you.
Please.
You showed the results with an infrared laser.
Mhm.
What is the performance with our additive with the UV and a green laser?
It's a good question. So we focused on infrared laser as the, let's say, the core of the market. UV laser is, how you'd say, more powerful, but there is typically less need for an additive in combination with a UV laser. But what we see is that you can achieve still dark markings and good contrast with this additive in combination with the UV laser. We just see it as being a smaller part of the market for us. Same is also true for green laser. It is compatible. It's not been our focus because of the requirement there is not quite the same as it is in infrared. So we're still excited to test it in combination with those technologies. We just need customers to partner with.
Okay, thank you. And now you are focusing on dark marking. Is it also possible to get a light marking with your technology?
Yes, it is. So it works in combination with certain black formulations. Carbon black, for example, can be slightly tricky in laser marking formulations. So it's a real formulation challenge to formulate blacks in combination with the laser marking additive. But theoretically, yes, this can work in combination with carbon black to still get white markings on a black background.
Okay, thank you. And my last question, you were showing the performance of your laser marking additive in clear polypropylene, which is used in packaging. Do you have food approval?
It's a good question. Again, not yet, but it's something we're working on as part of the development of the project. We see that market needs food contact to really grow. So it's something that we're going to work on over the next few months to develop that product. And like I said, it's an entry into that market, and then we hope to learn more and bring other products that have different chemistries and different solutions for not just polypropylene, but also PET and other transparent polymers. Films, for example, as well, is an area we'd be interested to work on. So I think that's the exciting thing, is the range of possible applications is so wide. It's really, once we have the technology in the market, there'll be so many different applications. It'll be great to just get it in there and see what it does.
Okay. Thank you, Dane.
Thank you.